Hi, welcome to Unit 8, Day 1. This is Intro to Acids and Bases. This is Part 1. In this video, we're going to cover 5 topics related to acids and bases, and in Part 1, we're going to look at properties of acids and bases. All right, so what I want you to think about is what comes to mind when you hear the word acid. If you want, you can pause the video or just take a few seconds to think about it. So here are some things that come to mind when I think of the word acid. Starting with food, my favorite thing. There's some foods that I think are acidic, like pickles and citrus fruits. I also think of things like acid reflux, because I hear that word a lot. Growing up in the 80s, I remember acid wash jeans. And in bio class, I remember learning about nucleic acids, which are the things that sort of hold and bind DNA together, and also amino acids, which are the building blocks of proteins. These are amino acids, and these are the nucleic acids. I also, as a chemist, remember the reaction of metals with acids like HCl, and you'll notice that there's bubbles, and the acid will break the metal down. I think about acid rain when it comes down to pollution, and then also, more tragically, I know that there have been people who have been victim of acid attacks. So the reason why I want you to think about what comes to mind when you think of acids is because you probably already know some properties of acids just based on your experience with that word. So let me introduce you to some of the properties that you know. So acids taste sour. So like I said, when you think about things like lemons or pickles or vinegar, right? Those are sour tasting things because they're acids. We also know from the lab that when we've put metal with acids, the acids will often break the metals down. So acids break metal down. And in terms of how they interact with our skin, we know that they can be poisonous and they can be corrosive to the skin, leading to acid burns, for example. So these are some properties of acids. And understanding or knowing these properties will sort of help you link your new knowledge about acids to these things that you've seen here. Let's think about properties of bases now. So if you want, you can pause the video. What comes to mind when you think of bases? All right, so a lot of people don't really know many bases because it's not something that we talk about as frequently. Bases have all sorts of names, or things that are basic are called, for example, alkali. All right, so if you think about that special water that costs a lot of money, the reason why that water, quote unquote, costs a lot of money is because they put some minerals in there to raise the pH so it's slightly basic. But here are some other things that should start coming to mind when you think of a base. Notice that a lot of the items here are cleaning products. Well, a lot of cleaning products are made from bases. And then if you think about antacids, which kind of makes sense, they're anti-acids, right? Bases are often used in acids to combat things like heartburn or acid indigestion. Baking soda, interestingly enough, it is an ionic compound. It is a salt, but it's a basic salt. Okay, so baking soda is basic. So what are some properties of bases? Before we go into that, though, I wanted to tell you something really cool about bases. Remember how I mentioned how a lot of cleaning products are bases? Well, actually, the reaction of fats and bases are used to make soap. That's called saponification. So, and that looks like this. You have your fat here, your triglycerol, and you have your base, sodium hydroxide, NaOH. And one of the products you can get from that is soap. So if you ever make homemade soap at home, you're probably using something like lye, which is sodium hydroxide. Now, another way that you know bases with oils or fats make soap is if you ever get bleach on your hand and you'll notice that it will feel very slippery and it's kind of hard to get off. Well, that's because the bleach has a base in it, and that base reacts with the oil in your hand to create a soap, and that's why it feels very slippery and it's kind of hard. You really got to wash it off. Okay, so this is something that's cool about bases. It's actually used to make soap. All right, so let's look at properties of bases. First of all, in terms of taste, they taste bitter. We don't think about a lot of foods as being basic, but foods that are slightly basic or have compounds in them that are basic taste bitter. They also break down fats in the process of saponification, and they'll feel slippery on your hands because they're turning the oils in your hands into soap. So why did we go over the properties of acids and bases? Like I said, I think by having some context or some schema, when you think about acids, you're thinking about a certain thing that will help you to better understand new knowledge. And the same thing about bases. So when you're thinking of bases, having the idea, oh, I'm thinking of a cleaning product like bleach or ammonia can be helpful. All right, so let's try our first CFU. Which of the following properties is a characteristic of acids? Select all that apply. So pause the video now. When you press play again, the answer will be revealed. All right, the answer is 3 characteristics of acids breaks down metals. They taste sour and they're corrosive to the skin. All right, now let's go ahead and move into part 2. In part 2, we're going to actually define acids and bases. So we've seen their properties, but how do we define them? And then we're going to learn how to recognize them from their chemical formulas. All right, so when it comes to defining acids and bases are defined by their chemical behavior. And there are 3 main definitions that are used. The first definition is the Lewis definition. We're not going to cover that here, but if you are planning on going the pre-med or life science or chemistry track, you are going to take a class called organic chemistry. It's one of the more difficult early classes that you take as a sophomore or freshman. And this is the definition that's used there. So it's an important definition, and it's actually an all-encompassing definition, but for our class, it's not the most helpful. The 2 for our class that are helpful are the Bronsted-Lowry and Arrhenius definition, which fall under the Lewis definition. They're a little bit more specific. We're going to start by looking at the Arrhenius definition because that is actually the most helpful for many of the things that we look at in this class. So this is the one that you really should know. For an acid, according to the Arrhenius definition, acids release H+, also known as an acidic proton, when dissolved in water. So let's take a look at where that H+ comes from. And we're going to look at the chemical structures of acids. And I believe we've already covered this in a previous units. So acids you can recognize from their chemical formula because they have an H in the front and a Cu group, which is this group here, in the back. Okay, this carboxylic acid group. And so here are some examples. You see the H, the hydrogen in the front of HF, HCl, H2SO4, and H2S. And then you have this Cu group in the back for vinegar. So that's how you can recognize that they're acids. So let's take a look at the structure of acids. There are 2 main types of acids in terms of understanding their structure. There are binary types, which are just made of 2 types of atoms. So hydrochloric acid, for example, HCl, and hydrosulfuric acid, H2S. You'll notice that in those cases, these are just covalent molecules, and the hydrogens are attached to very electronegative or relatively electronegative atoms. On the other hand, for oxyacids, the hydrogens are attached to an oxygen in a polyatomic ion. And it's important to know in this case that the number of hydrogens is equal to the amount of negative charge in the polyatomic ion. So let's take a look at an example of that. Here's nitrate. It's a polyatomic ion. It has a -1 charge. So how many hydrogens do you think the acid form of nitrate will have? 1, because if the anion had a -1 charge, the acid would have 1 acidic proton, 1 H+. For sulfate, it has a 2- charge. So how many protons should it have? It will have 2 of them. So the acid form will be H2SO4. And similarly, if we look at the Cu group here, for the Cu group, it has a -1 charge. So how many acidic protons or acidic hydrogens is it going to have? It will have 1 because that matches the number of charge. So the charge of the polyatomic anion matches the number of hydrogens in the acid, okay? And you can see that here in this chart. If you need to, you can pause it to sort of read through the chart. We're now going to move on to a CFU where we're applying this knowledge, figuring out how many hydrogens are in the acid that comes from the polyatomic anion. All right, so what is the chemical formula of the acid corresponding to the polyatomic anion PO4 3-, which is known as phosphate? Pause the video now. When you press play again, the answer will be revealed. Great, the answer is H3PO4. So phosphate has a -3 charge, so its acid would have 3 hydrogens. All right, now let's talk about bases. So bases, whereas an acid releases a hydrogen or H+ in water, and we saw where the H+s were in the acid formula, bases release OH- when dissolved in water. Let's take a look at what they look like. There are two types of bases. There are metal hydroxides and amines. Let's start with metal hydroxide. So an example of that will be NaOH, sodium hydroxide, or CaOH2, calcium hydroxide. And hydroxides are polyatomic ion, or the polyatomic ion OH minus. And if you look at the structure, this is the Lewis dot structure of these compounds. These are actually ionic compounds. And you'll see here that their hydroxides are OH minuses on these compounds. Now, that's important because if bases release OH minus when they're dissolved in water, according to the Arrhenius definition, you can see where the OH minuses are coming from. But what about amines? So amines, first of all, are compounds made with nitrogen that has three things, and those three things can be either hydrogens or they can be hydrocarbons directly attached to the nitrogen. So here we have a nitrogen and we have three things attached to it. And you can see that in these structures as well. So nitrogens are here and there are three different things attached to it. Now, according to the Arrhenius definition, the bases will release OH minus when dissolved in water. But as you can see here, the amines don't have an OH minus. So that's kind of strange. It's like, well, where's the OH minus come from? In the metal hydroxides, I can see they come from the metal hydroxides, but not from the amines. We're actually going to pause this and discuss this later, but it's important for you to be able to recognize that NH3 or something similar to that, any amine, is also a base. So it's either a metal hydroxide like NaOH or an amine like NH3. Now, one final note here, some things are actually both acids and bases. And that's called something that's amphoteric. They can behave as an acid or a base. And water is an example of that. So if you look at water, which is H2O, we can also write its structure as HOH. And the H in the front, that part there would represent our acid, and then the OH will represent the base. So when you dissolve water in water, because water can actually dissolve itself, it will break apart into H plus and OH minus. All right, here's your next CFU. So the main thing is, can you recognize an acid base or something that is neither or both? All right, so you want to pause the video now. When you press play again, the answer will be revealed. And if it's helpful for you, you could go back and look at your notes, but quick hint, acids, you have an H in the front, Cu in the back. For bases, you're looking for a metal hydroxide and also an amine, so something like NH3. Okay, so let's go through our answers here, and I kind of highlighted the important parts so it's easier to recognize. All right, these two here, KOH and CaOH2, they're bases, they're metal, so calcium is a metal and potassium is a metal hydroxide. In C2H53, that is triethylamine, and this is dimethylamine, NHCH32. These are bases, so there are nitrogen in the middle and then three things sticking off of that. HNO3 and H3PO4, they're acids. You see the H in the front. And then these two are acids. They have the Cu group in the back. Remember, the Cu group can be written as CO2H or can be written as COOH. Look at some things that are neither. So KNO3 is a neither. That's actually a salt. It's an ionic compound. C2H5OH may look like a base because it has an OH group, but that C2H5 is not a metal. So in order for it to be a base, you have to have a metal and then an OH. This is not a metal, so it's not. NO3 minus is neither. Acids and bases, again, you're looking for OH or H in the front or something like that. And then finally, remember, water is both. It's amphoteric and act as both an acid or a base. All right, that is it for parts 1 and 2. The next video will cover parts 3. Have a quality day.